Hello everyone. Today I am excited to share with you a brief overview, just a brief overview of a project where we aim to utilize GIS technology to build a nested model in ArcGIS. That is, a model within another model. You see, our goal is to gain a better understanding of our urban environment in general, and specifically we are referring to a particular city. To achieve this, we want to focus on mapping deciduous forest within 100-meter buffer of all major roads within a particular study area in a city. And why is this important? You see, this will allow us to assess the potential environmental impact of road extensions, and this will aid or decision making for urban development. So that is why the title of this project is a GIS based environmental impact assessment, mapping deciduous forest proximity to major roads in urban areas using nested models. You see, now let's visualize this project. Let's visualize this project flow with a schematic drawing. And in this first model, we are going to create 100-meter buffers on both sides of the road network. As you can see, let's say this is the road network. We are going to create 100-meter buffer on both sides of the network. Now, to streamline our focus, we'll introduce study area boundary data, as you can see, and this will now result in a refined output in which we showcase only the buffered roads within a specific study area, as you can see in this case. So this snapshot ensures a targeted analysis of the road impacting our chosen urban environment. Now let's move on to the next model, which is the second model, as explained by the next slide. You see, what we have here is a study area that has a landscape which includes the vegetation, urban and rural structures. Let us imagine that these blue structures, this blue shape, represents deciduous forests within the landscape in our study area. Now we want to invoke the select tool, which would help us to filter only the area of interest, the vegetation of interest within our study area, and in this case, which is the deciduous forest. So what this model is going to create is going to create the deciduous forest from the group of vegetation, rural and urban structures within our study area. And from there, we will now introduce the intersect tool, which is where it actually gets interesting, where we will introduce the first model and intersect it with the second model, like nesting it inside the second model, from where we are going to input both into this tool called the intersect tools that will now bring both and create and generate for us a deciduous forest within 100-meter buffer of all the road network within the study area. So this brings the environmental context with the spatial relationship to major road network in the study area. So welcome to the actual project in ArcGIS Pro. These are our three major datasets that we need for this project, which can be imported, which we imported. Coming to Map tab, I'm going to add dataset, data, And from there, we can navigate to wherever we store the data set and import that into the project. So now, on this page, what we do is we go to analysis. In order to build the model, we go to analysis tab, we click on model builder, and that creates a blank page for us where we can build our model. And don't forget, the first model that we are going to build is the model that is going to create 100-meter buffer for every single major road within the study area. So we start by dragging in the major roads dataset, and then we go to the geoprocessing tool. The geoprocessing tool naturally can be accessed coming to analysis and clicking on tools. So if you click on tools, you're going to have the geoprocessing dataset open for you. Whatever place it's been open, it is open to. So coming to the geoprocessing tool, we can type in buffer. When you type in buffer, you can see it brings this buffer analysis tool, which you can utilize. You can drag it out. Yes, we drag it to the model page, and now this buffer tool is what is going to create for us the buffered 100-meter buffered road. So from the major road will be the input for this buffer, and we click on input feature for that. So clicking on input feature, then we double click on the buffer, and from there we can fit out some characteristics of our output. Now this is the input and this is the output name, the input name, the output name, and we can see from the unit that we want to work with. We say we want to work with linear units. As you can see here, we say linear unit, and we say what is going to be the measurement units is going to be in meters, and we're going to say it's going to be 100 meters. So that is the buffer distance from the road. And we have the full side is full, end type is round, and method is planar, that is just want it to be on a plane. And dissolve type, this is very important. What we want is we want our buffer to be dissolved into each other if we have a situation where we have an overlapping. So that is why we are going to choose dissolve all output features into a single feature in this case, and we click OK. So that is going to give us an output, which is going to be what the buffer. This is going to be the buffer 100-meter buffer road that we talked about. Now the next thing is to introduce the study area so that we can capture all the buffered major roads within our city in the study area only. So we drag in the study area. On dragging in the study area, the next thing that we are going to do is we are going to go to the geoprocessing tool again, and we call on the clip tool. In this case, we type clip, and we can see clip analysis. And on clip analysis, what we are going to do is we're going to drag out clip. As you can see, we drag out clip, and then we will drag the study area, drag from the study area an arrow into the clip, which is showing that you are actually using the study area in the clip. And now this is very important. In this case, the drag arrow is going to be a clip feature, not an input feature, because we are using it to clip major road. Now the major road will be the input feature, which is what we want to clip. And as you can see, we click on input feature, and that is that. That means this model is complete. So you can see, and now this is going to be the final output, and this final output can be made to be a parameter so that it can be used in the next model. How do you do that? You right click on it and you click on parameter. Then you're going to see something like P by it, which means it can be used, the output can be used in another model. We now proceed to the last dataset, which is the dataset that contains the landscape inventory within our study area. So we come to this dataset. This is the Soloist within study area dataset. If you right click on that, we quickly check the attribute table. Under the attribute table, what do we see? In the attribute table, we can see that we have different kind of attributes. Here we can see we have different types of inventory. We have the deciduous forest, we have the swamp, we have different kinds under the class type of the landscape inventory within our study area. So now But however, we have all of this shown with only one symbol. Shown with only one symbol. If you come to the map, you can see if you click on it, it's just one symbol. So what we want to do is we want to create different symbols for these different types of inventory within our within our environment, within our study area rather. So we right click on that, we go to symbology, and you get the symbology, and you can see just a single symbol for everything. So we come here and we choose unique symbols. And now what is the attribute that we want to use to separate this symbology? And that is going to be the class type. So the class type, you can see it gives us about 13 symbols. We don't want show all other symbols, so we take that out. So we have 13 symbols. If we come back to the content page, we can see now that we have different kinds of landscape inventory within our study area shown. And what we are interested in is the deciduous forest. Deciduous forest. That is what we are interested in. So now to continue with that, we now go ahead to build the model for that. So that is the next model in which we are in. And we say we drag in the data set, dragging the data set, we now go ahead to the geoprocessing tool to get what we call the select tool, as we have explained in our graphical explanation. We bring in the select tool, and now we can drag in the data set into the select tool so that it serves as an input feature for the data set. And this is the output for that. For this. We can also rename this output, and it's better to right click on it and make it as a parameter as well, because we might want to use this model in another model. So this is the second model that's going to bring the decidual forest. So how are we going to now select the decidual forest? We double click on select, and now we have the window open for us. So we can select the class type that we want to use to bring about decidual forest. And that is the class type, which is, you can see, select where class type as an attribute is equal to what? Is equal to deciduous forest. Where that attribute is equal to deciduous forest. That is only what we want this select to select for us. And in clicking that, it says okay. So we have that output for the second model. Now the next step is to integrate both model. To integrate both model, the first model, and which is this one, and the second model, now we will move in the first model into the second model, so that it's going to be nested to. So we bring in the model, the first model. As you can see, this is the first model, which gives us the output, and we are now going to use this first model as an input into a particular tool called the intersect tool in this case. So if the intersect tool can also be gotten from the geoprocessing tool. So we bring in the intersect tool. As you can see, we bring in the intersect tool, and from the intersect tool, we will now input both output from the first and the second model. So you can see it goes to the intersect. This is just the same thing that we showed in our graphical explanation initially from the PowerPoint slide. So as you can see, and this gives us the final output of our model. This final output of our model is what will give us only the deciduous vegetation within 100 meters of our buffer road. So we make it as a parameter, and again we will now say we want to display it, add to display, so that that display can come on this left hand side of our screen and we can see what the result is. So we say add to display, and after we have done that, the next thing is to run this model and see what actually happens from this model. So we click run. And as you can see, it says it's successful, and we'll close this. Then we can navigate to map and see if it works. We click on map, and we can see now, if you click on the major roads and you click on the study area, you can see this is the output that we generated. and this is symbology for the deciduous vegetation that was retained within that major road. And as you can see, we have some roads that are proximal, to deciduous forest, which is going to be challenging to extend such roads. They are proximal to it, as you can see here as well. So in general, this is how to get that, and we will now have to carry out more assessment. If we want to expand this kind of road, we need more assessment to check about the habitat, both animals and plants in those forests, and see what is going to be the impact of extending such roads. Thank you. So that's it for now. See you again next time. Bye bye.